Hello, ladies and gentlemen. I wanted to start skill 26 by saying that this skill is about doing the first derivative analysis algebraically with an equation. Be prepared to do a lot of computing with this, but you won't need any graphs. And actually, the fact that we're able to do, a first derivative analysis will help us determine when graphs are like increasing or decreasing and that type of stuff, or finding those critical points without even needing to look at a graph. So first thing that you want to do, step one, is take the derivative and set it equal to 0 to find the critical points. And that's what you're always going to do. And then the next part is after you find the first derivative, you're just going to plug in some x values into the first derivative. So, like let's say that my critical points were like two numbers that I call like a and b, and maybe I have a positive, and then maybe I try a number that's between a and b, and then I try a number that's greater than b. So what this would tell me is that what goes up comes down, and then what comes down comes back up. So this is where your maximum would be, and this is where your minimum would be. And at times, we also want to make sure that we are evaluating our endpoints as well. All right, let's take a look at some delta math examples now, shall we? All right, this first problem here, this says find the x coordinates of all relative maxima. Sometimes you may see a question like what's the relative minima, but they basically are asking you to do first to find the critical point. So this means take the derivative and set it equal to 0. This is deriv equal to 0. F prime of x equals 0. So I'm just going to take the derivative, and we're just going to use it. So I got negative 3x squared minus 14x minus 16. So that is our derivative. I'm just going to kind of box that so we can continue using that. So I have negative 3x squared minus 14x minus 16 equals to 0. And then now we're just going to kind of like factor and solve. So when I do that, I would do like an ACB chart, to factor. And the numbers that work are like negative 8 and negative 6. So let's see, the 6 goes with the 3. So I would do that. And then I have a minus 8x minus a 16 equals to 0. And one thing that you definitely want to always remember is that if the first term that you're pulling out is negative, pull the negative sign out with it. This is where kind of people make some small mistakes sometimes. And then over here, you kind of do the same. So like the negative 8x and the negative 16. So I have negative 3x times x plus 2. And then I have a minus 8 times x plus 2 equals 0. So I got minus 3x minus 8 equals 0, and x plus 2 equals 0. And I'm just going to kind of move this 8 over to the other side. Divide by negative 3. And then on this one, I got minus 2. So I got x equals to negative 2. And x equals to negative 8/3, or about negative 2.67. And these are my critical points. Next, I'm going to make a sign chart. So I'm going to kind of use my first derivative. So my first derivative equation is negative 3x squared minus 14x minus 16. And I'm going to kind of put the negative 8/3 on the number line and negative 2 on the number line. And I'm going to think about what is a number that is less than negative 8/3. So maybe a convenient number for me would be like -3. And if I try that, I'm going to have, when I do that, I'm just going to put in -3 times -3 squared minus 14 times -3 minus 16. And it gives me a -1. And all what I care about, and I like to kind of put the number that I plugged in parentheses. So I tried a -3, and I got a negative number there. So that means that that derivative is decreasing at that point, or that the function is decreasing at that point. Not necessarily the derivative, but the function is decreasing at that point because we have a negative first derivative. Maybe a number that is between -2 and -8/3. I may want to try like -2.5, and I would try -2.5 there. And what I notice is I'm actually getting a slightly positive number. So I'm going to put a plus sign. And then maybe, well, an easy number that I can try that's greater than -2 would be 0. And this happens to be also a negative number. So what I notice here that's going on, remember when we have a first derivative that is negative and then going positive, that means that our graph is going to be kind of shaped like that. And then I go from a positive first derivative, so this is increasing, and then I'm going to decreasing. So right there would be the max. And I only have one, so I'll put a -2 in there. And then we're good. And you can kind of see the sign chart that they do on here as well in the solutions. So they did like -3, -7/3, and 0. So they could even like show you, they actually kind of did like the factored form. That's fine too. I just kind of went right into doing the equation. All right, next type of question. This is going to be basically using your sign chart to determine when it's increasing and decreasing. Like the other question, you're going to want to find the critical points. So I'm actually going to take my derivative and set it equal to 0. This is critical points first. And then I'm going to do my sign chart after that. So I have -3x squared plus 21. And I'm going to actually, at this point, pull out a -3. And I'll have a x squared and let's see, -3 times -7 is 21. So I have x squared minus 7 equals to 0. So move that 7 over to the other side. So I get x is equal to plus or minus the square root of 7. So I'm actually going to do the minus square root of 7 and the square root of 7. Square root of 7 is about a number like, maybe 2 point something, close to 3. So maybe I would try like -3, 0, and 3. And remember, you always want to make sure that you are plugging it into the derivative. So I'm going to go to my calculator now. And I'm going to just go to my derivative. So I have -3 times -3 squared plus 21. That's a negative number. And then it's asking us for when it's increasing now. So I'm going to then try a number between -√7 and √7. So I'm actually just going to try 0. And I get a positive number. And then maybe I could try 3 and I get a negative number. So it's kind of negative, positive, negative. So what this means is that we are increasing in the interval between -√7 and +√7. And then we're decreasing from like -∞ to -√7. And then we're increasing from, and also decreasing from √7 to +∞. And it's asking us for just the interval in which we are increasing. And if I just write SQRT, it will give me a square root symbol, put a negative sign, and make sure that you're kind of outside of the square root. And then we have a square root of 7 as well. And we're good. All right, just one more type of problem. This type of problem, we looked at the maximums or minimums algebraically. So we actually need to look at the endpoints as well. So they actually give us some endpoints, and we need to find the critical points. So why don't we find the critical points first? So please continue to get in the habit of doing that. So I'm going to take the derivative. I like pulling out a 3. That just makes my numbers a little bit smaller, what I need to factor. And I get, as a result, a x plus 2 equals 0, and another x plus 2 equals 0. So I get x equals -2 and x equals -2. That's my critical point. And it's asking for the absolute maximum. Now, what I would do here is I would actually just do a f of x table. So I'll look at -4. This is my endpoint. Then I look at my critical point. So I look at all the critical points, and then I look at my other endpoint. And I'm actually going to do f of x. Not f prime of x, but f of x, and I want to see what my y values are. So I'm actually just going to do my f of x, but I can just plug in and see. So I could just go to my handy dandy calculator. So I'm just going to try plugging in -4 first. So I'm going to go -4 to the third plus 6 times -4 to the squared plus 12 times -4 minus 9. And I get -25. Now I could actually just graph these 3 points and actually get a pretty good idea about what the curve is going to look like. And then I'm just going to try plugging in -2. So I'm just going to put -2 in the parentheses now. And I get -17. And whichever is the largest of the numbers that I plug in will be my absolute maximum. And then I also like to try -1. So I'm going to try that. And that's going to be -16. So this happens to be the largest number. So this would be your absolute maximum. And it's just asking us for the maximum value of f in the closed interval. And then we're good. And you can kind of just see, that it's kind of an XY table, and the critical points tell us a pretty good place of where we need to go for that. So if we want to find those absolute maximums and minimums, I just kind of recommend finding those critical points and then actually just finding the Y values themselves. Now, if I'm asking for like local maximums and minimums, and it's not saying like, it's just saying what's the X values, then you're going to want to kind of go and try your first derivatives to kind of assign you, your local maximum or local minimum. So these are going to be your main types of delta math examples, and definitely make sure that you are using that scientific calculator very well, because that does come quite a bit in handy.